This is SAT Practice Test 9 from the Bluebook. The whole math section is supposed to take 70 minutes. I'm going to do it in about half that time, get a perfect 800, and walk you through every shortcut I use along the way. By the way, I built a tool to help students practice exactly this kind of thing, and I'll show you that in the middle. Let's go. All right, first one here. Open up Desmos. Like to have it half the screen. This one's an equivalent problem. You can do these in Desmos, but this one's pretty basic. Just, add your like terms, 2x squared plus x squared. It's got to be a 3x squared one, right? X plus 6x, 7x, and then negative 9 plus positive 1, negative 8. You can do this in Desmos, by the way, right? I'll show you that really quick. The idea with these equivalent ones is just whatever they give you has to match one of these answer choices, right? So see, I can just type this into Desmos, and I'll get a graph, right? And now just to show you, these going to be the same exact graph, right? So even if you didn't want to do algebra, or some of them are going to be a lot more difficult, this is the idea of equivalent, right? It just means like literally what they give you has to match one of those. So this is a cool trick you can use in some harder problems. Next one here, just a reading problem. John paid a total of $165 for a microscope by making a down payment of $37 plus P monthly payments of $16, right? So just translate this, 37 plus something, right? And it's got to equal 165. So C is the only one it could be, right? Next one. These are very popular. Every test has these. They're going to vary in difficulty. This is a pretty simple one. They give you an equation, and you need to just isolate it for a variable or whatever, right? So here you can see all the answer choices are isolated for M. So if I want to get M by itself, I'm going to get rid of the 7. So I'm just going to divide both sides by 7. That's going to be A. That's pretty simple. Function question. Just throw this into Desmos for number 4 here. See, we can just kind of write in a function and we can just kind of evaluate it and we get 5. That's it. Pretty simple. Next one here, probability, right? So we got table and it's probability. So it says if one of the students is selected at random. So that means we can select out of all the students. So we want our denominator to be 80. And what is the probability? They chose lion for a mascot, right? So 20 people chose lion and that's 20 out of 80. Right, so that's a pretty simple fraction to reduce, but here's the thing you want to know in Desmos. If you put in a fraction, you can click this button over here and it'll change it to its reduced fraction, right? But that's just probability, right? So again, probability, the denominator is the total and the numerator is like the favorable, right? So here's like a little image. Here's a little trickier one, by the way, if you want to take a look at that and pause the video. But this one's pretty basic. Next one, student council group is selling school posters for a fundraiser. The function P of X equals 5X minus 220 determines the profit P of X for selling X school posters. In order to earn a profit of 900, how many school posters must they sell? So here's a cool thing about like functions. They're always going to describe to you what the variables are, right? So like here, they tell you what P of X is, that's profit, and what X is. You need to know that because like in this question, they're just telling you profit's 900. So I can replace P of X with 900. I can just zoom out. Here's my answer for X. That's how many posters it would be, right? So you need to know one to answer for the other. In this case, we know profit, we're finding posters, or vice versa. If you wanted to find profit, you'd enter in posters, right? Okay, next one here. We just have this kind of scatter plot, right? And they want to know what's the linear model that would be most appropriate for this. So the really cool thing in Desmos, if you watch the other videos, you should be familiar with this. Just add a table here and just put in 2 points, right? You can kind of estimate these points. Whatever kind of looks kind of like it's intersecting nicely. I'll go with 1,9. That's about there. These don't have to be perfect. You'll see there's one that's much closer than the other. And you just need another point. So I'm going to go with 4,3, right? You put in your 2 points. This button appears here at the top left. You hover over, it says add regression. Click that button. Here's your linear regression. So we're looking for something that's closest to this. So negative 2x plus 11. Closest one is B. This one's pretty simple again. We're in module 1, right? You can see that the y-intercepts should be about 10, positive 10. So it couldn't be A or C. And then the slope is negative, right? So just looking at it that way, you can figure it out as well. But that's how you can use Desmos to do regressions. Next one, systems. Systems are great. Just throw those into Desmos, right? Type it in exactly how you see it. You don't have to change it. That's the great thing about Desmos, right? I just type those in. Make sure you're zoomed in correctly. And here's our answer, right? And they want to know what's the y. It's just 1. Next one here, we got a table of values and it says, what's the maximum data value, right? So what we want to understand here is what frequency means, right? I mean, for this problem, it's not that important, but I might as well mention it anyways. Frequency just means how much of a number you have. So if they say frequency of 3 for 6, we'd write the number 6 3 times. And then again, we'd write the number 7 3 times, right? Let's say you needed to calculate mean or median. That would be really important here. Here, they're just asking you what's going to be the maximum data value, right? So if you're writing out all these numbers, the last number you're going to write is 14, and you're going to write it 6 times. So the largest number in the list is going to be 14. Next one. Circle K has a radius of 4 millimeters. Circle L has an area of 100 pi millimeters squared. What is the total area in millimeters squared of K and L? So this is an area formula, right? This reference button here, you have that on the Bluebook, right? It gives you some formulas. It does give you area of a circle. Hopefully you know that, but there's some basic area formulas. It's more useful for these volume formulas. That way you don't have to kind of memorize those, right? But circle, just pi r squared. So here it's 4. The radius is 4. So square 4, it's 16. 16 pi plus 100 pi, we get 116 pi. Next one, over here, you get an equation and they want to know what is 4 minus 3x. You can solve this algebraically. It's actually not that bad. Just move things around. But here's a cool thing you want to know as well. If you get an equation like this, you can just type an equation into Desmos. Again, you don't have to simplify it or do any math, right? You see, I can just type it in exactly as I see it. And let me just make this equation field a little bit bigger so you can see it all. There it is. And if I zoom out, you see what I find is x, right? You type in an equation, you're going to know what x is. That's what I need to answer this question, 4 minus 3x, right? 4 minus 3 times negative 4. We get our answer 16. You could have also done this algebraically. You see, there's this quantity, 8 of this 4 minus 3x. If you subtract it to this side, it's just going to be 4 minus 3x, and you subtract 2 to this side, you get 16. So you don't need to do that, but just FYI, right? Next one, triangle FGH similar to JKL, right? Similarity is something we have to know, right? We have a picture here about similarity. Here it is, similar figures. 3 properties you want to know, right? First one, corresponding angles are equal. That's a common question you get. Corresponding sides are proportional. This is the money one for this problem. Corresponding angles have the same trig ratios, right? So FGH is similar to JKL. They tell you sine F is 308 over 317. They want to know sine J. It's the same thing. Why is it the same thing? Because F corresponds to J, right? So if you know that, you don't have to sketch out any triangles or anything. It's just, you just know it. It's given to you, right? Next one. Wire has a length of 106 inches, is cut into 2 parts. This is an important thing to kind of notice, right? If you ever have 2 unknowns, and that's what we have here, one part and the other part, you have 2 unknowns. 2 unknowns is a systems of equations, right? So here you want to write a system of equations. You want to be able to read this and write. So this first sentence is an equation. It would just simply be 106 equals x plus y, the 2 parts, x and y. Now it says one part is x inches and the other part is y inches. That's the same equation we got there. And now you see the second sentence, or third sentence, sorry, gives you the other equation. X, you literally got to translate it. X is equals 6 more than 6 plus 4y, right? You see, I got my 2 equations just like before. Any system you put in, you can click on their intersection point. They want to know x, 86, we move on. Next one, this is just a reading problem. A certain township consists of 5-hectare industrial park, 24-hectare neighborhood. The total number of trees is 4,529. The equation 5x plus 24y equals 4,529 represents the situation. What's the best interpretation of x? This is a really common question. I've seen this a bunch of times, right? People usually mess this up, but it's really simple. Let me kind of break this down for you, right? The most important thing in this kind of problem is what this number here equals, right? And it was trees, right? The reason that's important is because you see, the only way that's going to make sense then is if I do something like this. Trees plus trees equals 4,529 trees, right? If this thing has units of trees, this is the only way this makes sense, right? You can't have like bushes plus, I don't know what else, benches equals trees, right? They got to be trees. So what is 5x? 5x is trees. 24y is a total amount of trees, right? That's not what this question is asking us about. It's not asking about 5x or 24y. So it's not going to be about the total number of trees, right? And then the final thing is x is with 5, and 5 was for the industrial park. So you know it's A and not B, right? So if you remember this idea, and this is a common question, I've seen it in a bunch of tests. If you watched the videos before, you've probably seen a question very similar to this, right? So there's common things that you'll just repeatedly see, and once you kind of understand it, they're really simple. Next one here. We got this in exponential form, and you see the answer choice on radical form. So we got something here. You got to know how to convert from exponential form to like radical form, right? And so you see, in exponential form, the numerator is the power and the denominator is the root. The root is the number out here, right? So what you kind of want to do in this case is I would take the answer choices and just change them into their exponential form and see which one's going to reduce to be 11 over 12, right? So you see for A, right, the root is 12 and this is the power is 132. So for A, it'd be 132 over 11, right? That's just going to reduce to 12. It doesn't reduce to 1 over 12, 11 over 12, sorry. Next one is going to be 132 over 144. You see I changed that to its fraction. That's 11 over 12, so I know those two are the equivalent ones, right? So that's an equivalent one. You could also put that in Desmos. The way you do that in Desmos, you see, is I can kind of write this, and it'll draw this. I changed A to X, because if you have A, right, Desmos isn't going to draw it if it has A, right? So you see, not going to happen. So here I can draw it, and then you can see I can confirm B is the correct one. If you want this radical where you want to enter a different kind of like, not just a square root, if you click this, there's just a square root. You can't enter it, you can't modify, sorry, that root. You just got to go over here, functions. You can scroll all the way to the bottom here, and then there it is. And you see, if I enter this in, I'm going to see they're exactly the same. You see how it's kind of overlapping that one. Ignore this left side. It's just kind of something to do with the powers, why I graphed only one side for this other one. But these are ones that overlap, whereas you see if I change it to like A again, right, where this was 12 out here, they're not going to be the same, right? So you're looking for ones where they overlap, just like the first question we talked about, right? So that's why I mentioned that earlier. It's a useful thing if you're not sure, but it's multiple choice and it's an equivalent problem. You should still be able to put it in Desmos and just see like what matches, right? Over here, function question, right? So function question, just throw this into Desmos, x minus 2, x plus 6, right? Here's our graph, right? You want to know how to write your transformations, right? This talks about translating a graph up 4 units, right? So I can write this for g of x. I can just write g of x equals f of x plus 4, and that will literally move it up 4 units, right? Like if you compare these, you can kind of see how it went up from 135 to 139, right? So make sure you know how to write your transformations. Up and down, it's pretty easy. You just kind of add or subtract the number to the end of the function, right? If it was left or right, it's got to go inside the function, right? Anyways, now you see I have g of x. I can just ask you what's g of 0, 76, and we're done. Next one here, another systems. We saw this before. These are freebies, right? Just throw that into Desmos, right? Here it is, 4y equals 15x minus 8. Let me reset my zoom. Where do they intersect? Here's where they intersect. Just always be careful to read the very last question of a system. Sometimes they want x, sometimes they want y, sometimes they want you to do something with x and y. Here we got to do x minus y, right? So here's a little trick. You can click on this. It'll just kind of put that point for you. And I can just do x minus the y, you see, and we get 35. All right. Next one here. This is an exponential equation. It's important for you to be able to identify like what kind of equations we have on the test, right? So there's 3 main ones, right? There's the exponential equation, right? There's our linear equation, right? And there's quadratic equations. You want to be able to tell by looking at a function which one it has. This test really just tests on these 3 functions basically, right? Quadratics, right, has to have an x squared, right? Linear equations, they don't have any exponents. Exponential equation, what makes it exponential is the exponent is a variable, right? So we're dealing with just kind of like exponential here, right? So let me pull that up. Where did that go? Exponential equation, here it is. Okay, there's 2 parts that are really important, right? There's this number out front here. That's the y-intercept. It's the initial value when it's written like this one is over here. And there's this number in here that represents your increase or decrease in terms of a percent, right? This question's asking for interpretation of a y-intercept. So we know that's that number in front there. So you want an answer choice with 8,000 right off the bat, right? And then the other thing you got to kind of know to determine this, right? It's more general. It's just about intercepts, right? When you have a y-intercept, that implies that the x value, the value of x is 0, right? So here they're not using x, they're using t. And it says t represents the number of years since 1998. So you want one that says 0 years since 1998, which would be this, not 5 years, right? So hopefully that makes sense. You want to understand that the idea of intercepts, you'll see that frequently. Next one here, landscaper used a hose that puts 88x ounces of water in a bucket in 5y minutes, right? That's a ratio, right? Ratios are like 2 per in, those are keywords for ratios. So I can write something like this. ounces over, you see like this would be ounces on top and it's minutes on the bottom, right? And then over here, what does it want? It wants to know how many ounces. So you see that's going to be like our unknown here. And we know it's 9y minutes, right? So basically you just got to solve for that question mark. So the easiest way to do that is you just multiply both sides by 9y, right? So this would be 88x times 9y over 5y, right? And if you simplify this, right, the y's are going to just cancel out. And you just got to know what 88 times 9 is, right? So 88 times 9 is 792. So we want to see this 792x over 5, right? So that would be D. Next one here, keyword solution. These are also freebies, right? I mean, we saw that with systems, right? Systems, you're finding a solution. Any equation you need to find a solution for, just enter it in Desmos, just like you see it. You see square root x minus 2 squared equals square root 3x plus 34. You see these two lines are going to be our solutions. Normally you can click on it, right? Sometimes like here with radicals or some other ones, Desmos for whatever reason doesn't let you click on it. They want the smallest solution, which was this one here. Just zoom in on it. You can see that that's -3 and we're done. Okay, next one here, another similar problem, right? We talked about similar before. XYZ similar to RST. Okay, and then they tell us what corresponds to what. Usually it's in the order in which they name it, right? And then they tell you angle Z is 20 degrees, and they tell you this is about their proportionality, 2xy equals RS. That's kind of irrelevant here because they want to know angle T, right? So we kind of talked about this before. Now you want this first property, right? I say you need to know these three properties. This is the first one. Corresponding angles are equal. Z corresponds to T, right? So Z is 20, T is 20. That's a very common question. It's a really simple one. Doesn't require any math. You just got to read similar and know those properties, right? Next one over here, we got our function, right? So we can put in f of x equals 9, 4 to the x. And here they write the transformation for us, right? We talked about transformations a little earlier. This is a shift left 2 units, right? Usually they won't require you to kind of know how to write that yourself. Like remember that other one? It said it's up 4 units and we had to write it ourselves in the function notation. Usually with left and right, I've noticed like it'll just be written for you, but you probably want to know how to write like left 2 units if it said that in words, right? So this is our g of x, right? The green one. I'm going to turn off the graph for the blue one because we're not looking at that. We're looking at g of x. And the question just wants to know which one of these is g of x, right? You can do this algebraically, but you see, I can also just now put these into Desmos. And if it's g to the x, it should be the same graph as this green one, right? So it's definitely not A. So then I just change it to B, 144, and there it is, right? They're overlapping each other. If I turn off the purple graph, I see the green one underneath it, right? So that's it, really simple. And that's it for module 1, right? Yeah, not too bad. That was actually pretty simple module 1, I think. All right. Quick break before module 2. I want to show you something that I built that's directly relevant to what you're watching right now. The way you actually get good at SAT math is reps. When you've done 50 of a question type, the 51st one isn't difficult anymore. It's just obvious. That's what Sigma Prep is. Practice problems organized by topic and difficulty, a video explanation on every single one, instant feedback so you don't keep making the same mistake. But here's the coolest part about it. This exact test, the one I'm speedrunning right now, is on Sigma Prep as a full practice test. Same 2-module adaptive format as the Bluebook, same topic mix, same difficulty curve, but every problem is a fresh variation. So your score actually means something. And every test now comes in 3 unique versions. So when you retake it, you get brand new problems on the same skills. You can't memorize your way to a fake score. So when you're done with this video, head over to sigmaprep.io and take this version of the test yourself. See if you can recall the strategies I'm using here. If you do, you should walk out with an 800, just like I'm about to. And if not, you just need a little bit more practice. When you finish, you get your score and a full breakdown. Every question you missed has a video explanation where I walk through exactly how I'd solve it. And then this is the part that actually moves your score. One click builds you a custom practice set from exactly what you got wrong. You don't have to wonder what to study next. Just do the loop. Take a test, do the practice, get better, retest, see what changed. You can start for free. Your first mock test is free, and so is the diagnostic quiz if you want a 15-minute picture of your weak spots first. If you grind this out, there's no version of you that doesn't improve. sigmaprep.io, link in the description. Now back to module 2. All right, module 2. Number 1, open up Desmos, have this open. They want to know the median, right? So we got statistics here. these are 5 things you got to know for statistics. So median, middle number, but here's the thing. You want to know, you can just put median in Desmos, right? So median, mean, and standard deviation, you could calculate in Desmos if you want to know the number. So that's what I would definitely do here. Although this one is already kind of like in order, so it's not like too bad to do without Desmos. But you see, if I just type median and I just type in all my numbers, it'll just literally give me the result, right? So you want to know that about mean, median, standard deviation. The other 2 here, range and mode, they're pretty simple, but Desmos, you can't do them in Desmos. So you got to know range is largest minus smallest, mode is most common number, right? But this one we can do in Desmos. Okay, next one over here. Right triangles, LMN, PQR are similar. We saw a couple similar problems in the last one, right? L and M correspond to P and Q respectively. M has a measure of 53. What is Q? We literally saw this question in module 1, right? M corresponds to Q. So if M is 53, Q is 53 as well, right? Next one. We got this table. It says table shows 3 values of X and the corresponding values of Y. Here's our equation. They want to know what is A. A is the Y value when X is 3, right? This is pretty simple. You just type your equation in. And we can just kind of replace X with 3 because that's all it is. And we get our answer, just 35. Next one. How many solutions does this equation have, right? So you can type this into Desmos, but there's something you kind of want to know for these. Let's just go over here. Infinite solutions and no solutions. These are 2 special cases, right? Infinite solutions, this is a case of infinite solutions. As equations, it's when you have identical equations. So if you notice that, it's really simple. You can just kind of type this in and see, or you can just kind of look at this and just see that they're exactly the same, so it's infinitely many. The thing is, if you put this into Desmos, right, because remember I said if you have an equation, like here's a random equation, if I type this in, I'll see the solutions. If it was like, for instance, quadratic, I'd see 2 lines because there'd be 2 solutions. So if you do put it in Desmos, you see how many solutions there are, but you got to know for the special cases of 0 and infinitely many solutions. Here's a weird thing Desmos does. If I type in 66x equals 66x, you're not going to see anything, right? And that's going to throw people off, right? They're going to assume 0. It's just a weird Desmos thing. When there's infinitely many solutions, it doesn't show you anything as well, right? So what you can do, a safer way to do that if you don't see anything, just separate it. You see, if this is the left side on its own and I graph the right side on its own, I see they're exactly the same, right? And that was the other thing with this infinitely many solutions. They would be the same exact line on a graph, right? So a couple ways you can tell, but hopefully just by looking at that, you know it's infinitely many solutions. Next one here, model predicts population of Bergen was 15,000 in 2005. Predicts that in the next 5 years, the population will increase by 4% of the previous year, right? So again, if you look at your answer choices, we talked about this as well in module 1. These are exponential equations, right? So where was our exponential equation? There it is, right? Remember, we talked about it, number out front, that's the initial amount, that's the 15,000. So it's definitely, you know, C or D. And then the final thing, right, is this number in here, we said represents your percent increase or decrease. Here it says increase by 4%. So you see it's got to be 1 plus the 4%. So that's it. If it was a weirder decimal and you don't know what it is, you can just literally write 1 plus 4 over 100 and it gives you the decimal equivalent of that. Next one, function h gives us this equation. H of x has an x-intercept at a comma 0, y-intercept at 0 comma b. They want to know what's a and b. You just got to know what the intercepts are, right? So you type this function in, and that's something you can always click on in Desmos, right? You see, if I have my function, I can click on the y-intercept, I can click on the x-intercept. So I know a, the x-intercept's -7, I know b is 28, so we got to do a plus b, we get this, we get 21. All right, next one, another equivalent problem, right? This is the third one we saw, right? And like I said, they might get a little more complicated, right? So this you might not want to simplify algebraically. So this is when you want to know kind of that trick that I already showed you like a couple times, right? For an equivalent problem, you can just type in what you kind of see into Desmos and it will draw a graph for it, right? Here it is. Now, one of these literally has to match it, right? So I just kind of go through my answer choices. I put in A. Does that match? No. So it's not A. So I go and I put in B, right? So 8x minus 3 over 2. That matches, right? You see, turn off the red graph. There's the black one underneath it. That's the match. Simple. Equivalent ones should be freebies when they're multiple choice. Next one. Circle A has a radius of 3 ends. Circle B has a radius of 129 ends. The area of circle B is how many times the area of circle A, right? So you can actually calculate the areas. Just make up a number for n and you can literally calculate the areas. That'd be one way to do it. But a better way to do this, and you're going to see these questions, it's kind of understanding proportionality, right? If you know, for instance, the sides are 3 times bigger, the area ends up being 9 times bigger. Why 9? Well, area is units squared, and if it's 3 times bigger, it's like 3 squared bigger, right? And if it was a question about volume, it would be like 3 cubed bigger, right? So in this case, you see, the trap answer here is people are going to take 129 and they're going to divide it by 3, and you're going to get 43, right? So a lot of people are going to pick that. That's a trap answer. That would be asking how many times bigger is the radius of circle B than circle A, right? That's not what the question wants. It wants area. Area, again, is units squared, right? So you see, we got to just take that 43 and square it, and that's the quickest way to solve that if you understand that proportionality idea, and that's definitely a question you'll see again. So otherwise, calculate your two areas, divide it, and you'll see you get the same number. Next one. Circle has a center O and points R and S are on the circle. Triangle ORS has a measure of angle ROS is 88. What's the measure of RSO? So probably you want to kind of sketch this out, right? That's why you get scrap paper, right? I'm going to sketch it out over here. So we got a circle, okay? We can put in our center. They said the center was O. I'll label that here, center O. There it is. It's just right on top of my point there. Let me just kind of move this a bit then. There we go. Okay. And then we have two other points, right? So let me put those points here. It's like point R and point S. This should be a little bit bigger, but that's okay. So R over here, and let's put S over here. Okay. And then it said we have a triangle ORS, right? So if I kind of connect these, we stop there and then connect this one to S, and then finally connect this to R, right? So that's our triangle. Rough looking sketch, but that's okay. Anyways, what you kind of want to know with these triangle ones, you see, like if you draw a triangle in a circle, it's isosceles because OR and OS are going to be radiuses, right? So these are going to be in isosceles triangles whenever you kind of have a triangle formed with 2 points on the circle and O, in the center as well, right? So back to our problem, right? What did they tell us? They told us ROS is 88 degrees, right? So let me go fill that in. So here's ROS, right? 88 degrees. Let me edit that. I don't know why I put it there. So 88. So this is the vertex angle, right? And again, we know this is isosceles then. And the question was, what was the question? It wants to know what's RSO, right? So they want to know this angle, which is one of the base angles of the isosceles triangle, right? So this angle and this angle have to be the same. So now we know what we have to do. We just got to subtract 88 from 180 and just kind of divide it by 2, right? So let's go ahead and do that. 180 minus the 88 and then divide it by 2 and we get 46. So geometry ones, sometimes they're a pain because they won't give you a picture. And so that's why you have scrap paper, right? That's when you want to utilize it. Make a little sketch and then that problem shouldn't be too bad. Next one here. Business owner plans to purchase the same model of chair for 81 employees. The total budget to spend is $14,000, which includes a 7% sales tax. Which of the following is the closest to maximum number of price per chair? Before sales tax, the business owner could pay based on this budget. So you got to understand percents, right? This is a good percent equation to know. We can say the final value is equal to the original value times our percent increase or decrease, right? So here we know the final value, right? That was the budget. The budget's $14,000. We cannot spend more than that. We want to figure out what's the original price of each chair that we can have. And we got to include this 7% sales tax, which is going to be percent increase, right? So I just type that in. Final equals the original. It's 81 chairs times some original price that we don't know. And then times 1 plus 7%, right? And so you see then Desmos will just kind of solve it for us and we get our answer, right? So make sure you kind of understand that percent equation. That's a really useful one. Next one, right triangle has lengths of 24 and 21. If the triangle's hypotenuse is 3 square root d, what is the value of d? So here we get this in our trigonometry, right? That's kind of here in this picture. Trigonometry, SOHCAHTOA, and Pythagorean theorem. Those are 2 things you're going to get. This is just simply about Pythagorean theorem, finding the hypotenuse. Hopefully you know that, and that's like a really obvious formula for you, right? You just got to know hypotenuse is C, right? They also give that to you here in the reference sheet, right? But again, hopefully there's some basic things you just want to know. So my legs, that's the A and B. So I can write 24 squared plus 21 squared equals, and then I can put in 3 square root D, right? And then square that, right? Now, the only reason we're getting an error here, Desmos doesn't like the unknown to be anything other than X. So just swap that for X and you see our solution appears. I just zoom in on it. What number is that? That's 113. That's our answer. So Pythagorean theorems, you can just type those in Desmos and get your answer. Next one. Another thing with percents, but this one, you just want to be able to read this and translate this into equations. You see, this is an equation right here. A is 230% of the number B. Literally A is equals 230%, right? So anytime you get a percent, you can just write that number over 100. Of means multiply, right? Notice here, it didn't say increase or decrease. We're not doing 1 plus the percent or 1 minus the percent. It's just this. A equals 230% times B. That's one equation. Next equation. A is 60% of C. It's the same thing. A equals 60 over 100 times C now, right? So those are two equations. And even the question itself gives you an equation. You see, if you read it, C is P percent of B. So if I write that, C equals P percent, so P over 100 times B, right? Now, what this lets you do is just kind of like figure out like what you need to do to solve for P, right? If I wanted to solve for P, I'm just going to multiply 100 to the other side and divide by B. So it's going to be 100C over B. That's going to be what gives us P, right? I don't really need this equation. So to solve this, I really just need to know what C and B are, right? So if I just this is a really cool way to do this in Desmos. It just requires you kind of understanding the dependencies, right? I'm going to rearrange this equation. You see, I'm just going to solve it for C. So it'd be like C equals, and it'd be A times the reciprocal of that, right? You'll see why I'm going to do that in a second. I'm going to get rid of this one. Now, I just need to tell Desmos what B is, because when Desmos knows what B is, that's what it's telling me here. It'll figure out A. When it figures out A, it'll figure out C. And when it knows C and B, it'll give me my answer. So you see, I can put in whatever I want for B then, and it'll kind of calculate my final answer, 383.3%, right? And you can see I can change the value of B. C is going to change, A is going to change, but my final answer is always 383%. So hopefully that makes sense. If not, watch some of the other videos. This is like a pretty common thing. You can translate these. They're pretty simple. Next one. For x greater than 0, f is defined as follows, right? So it's another, literally just kind of, you see, there's a few questions where you literally want to read something and translate it. So if I wrote this equation, it would literally be f of x equals 201%, right? So that's going to be that of, so times x, right? What kind of equation is this? Well, if you look at it, it's a line and it's increasing linear, right? The trap here is people are going to see percent, right? And they're going to pick exponential, right? But the thing you got to remember for exponential, it's got to say percent increase or decrease, right? So this is actually linear, right? But the trap is picking increasing exponential. Next one, 14. They give us a table, and it says the table gives 2 points of a line, right? The y-intercept is k minus 5 comma b. K and b are constants. What's the value of b? So remember, if you just kind of put in 2 points into Desmos, right, it will just give you, you can then do a regression, and you'll kind of just get your slope and y-intercept, right? And we want to know what's the y-intercept. The problem is here, right, we can't do the regression yet because we don't know what k is, right? So that's going to be like what you have to realize in this problem. You got to figure out what k is, right? And how do we do that? Well, we talked about this a little bit earlier, right, about the intercepts. It's talking about a y-intercept, right? And we literally mentioned this in a question earlier. It was like best interpretation of a y-intercept for an exponential graph. If you're talking about a y-intercept, you got to remember x is 0, right? So this is the point, and you see this is the x coordinate, k minus 5, right? This has to be 0. So it's only going to be 0 if k is 5, right? So you see, now I tell Desmos k is 5. Now I can do my regression. I get my slope. I get my y-intercept. The question's about the y-intercept, so it's just 33, right? All right, next one. Keenan made 32 cups of vegetable broth. Keenan then filled x small jars, y large jars of the broth he made. The equation 3x plus 5y equals 32. What's the best interpretation of 5y? We literally saw this question in Module 1. So this honestly, a pretty easy test so far, because a lot of the concepts from Module 1 are just the same concepts in Module 2. Remember what I said, in that Module 1 example, what matters here, I think over there was about trees, right? What matters is what this equation is, what the units are for what it equals. It's 32, and the units were cups, right? Why does that matter? Because again, it's this idea, cups plus cups equals cups, right? So 3x has to represent cups of something, 5y has to represent cups of something. That's what the question is. It's 5y, right? So it's about the total number of cups, right? The one in module 1 was literally the opposite, right? And so 5y, right? And they told you y was large jars, so it's going to be C, right? Large jars. So hopefully that makes sense. But yeah, just another repeat of something we saw in module 1. Okay, next one, systems. This is pretty simple, right? We saw systems before. Just throw that into Desmos, right? If I type this into Desmos, it'll graph one. And what does it want? It says the system has no solution, right? We talked a little bit about this, knowing infinite solution, no solution. On a graph, what will no solution look like? It's just got to be parallel lines. So one of these answer choices has to be parallel with this. So you see, not A, right? So we try B, right? And there it is, B, right? Just move it around, make sure it remains parallel, and it does, right? So that's it, really simple. Next one here. This is an interesting question, right? This is definitely like a harder question, and most people, like, if you haven't practiced something like this, you probably not know like what's the best way to do this. But they give you an equation, and again, the keyword solution, right? So if we are asked for solutions, you can just type an equation into Desmos, and normally you just see the solutions, right? Right now we got an error, and it's important for you to understand why you have an error sometimes in Desmos, right? The reason we have an error is Desmos doesn't know what A is, right? So that's why we're not seeing solutions. So in this case, you want to tell Desmos what A is. So what's A? Well, they literally just tell you A is a number greater than 30. So I can go with, let's go with 40, right? I just tell it A is 40. And now you see my solutions appear. I can click on it. These are my two solutions. I can use this to answer the question because it's like, what are the solutions? So we see 29 is a solution. So we definitely want an answer choice with 3, right? And then what about the other one? Well, the other solution's 41, right? But this doesn't say 41. It says something about A. What did we make A? We made A 40, right? So Roman numeral 2 is then going to be 41, right? A plus 1. And you can see I can change, the value of A. If I make it 35, I'm going to have 29 still, but now I'm going to have 36. You're always going to have 29, and then the other one is always going to be one more than whatever you made A. So if you know that, you don't have to mess about anything with algebra. You just throw it in Desmos, get your answer. Next one, 1 gallon of stain will cover 170 square feet of surface. A yard has a total fence area of W square feet. Which equation represents the amount of stain, S, in gallons needed to stain the fence in this yard twice, right? So you got to just pick out the correct equation here, right? And in order to do that, one really easy way to do it is you can just find a combination for S and W to plug in and just verify what equation is made like true based on those points, right? So in order to kind of pick out that point, you got to know what these variables are, right? And you see, they always tell you W is the square feet and S is gallons, right? And they literally tell you here in the first sentence, S is 1 gallon, right? And W is 170 square feet. But there is one little twist here, right? They sneak it here at the end. It says they want to stain the fence in the yard twice, right? This would paint, 1 gallon would paint the 170 once, right? So if you wanted to paint 170 twice, you would just need twice as much gallons, right? So this is actually the combination I want, right? So you see, now I can test this, right? I want to be able to plug in the value for W, and I know that I should get a result of 2, right? So it's not going to be A, that's like the trap answer. It's definitely not going to be B or C, right? You plug in 170 times 170 or 340 times 170, it's going to be huge numbers, but it's going to be D, right? Because you see, if I plugged into that, 170 over 85 is going to give me my 2. So hopefully that makes sense. If you kind of understand that, it's an easy way to figure out what's the correct equation just by plugging in a point. Next one here, we get a quadratic and it says intersects the line y equals c at one point. What's the value of c? Normally this is a discriminant problem, right? If you've seen some other problems or some other videos, you've probably seen us talk about the discriminant. That's what you'd normally have to do if it wasn't multiple choice, which is why most of the time that question is not multiple choice. Because here, this one's like really pretty basic now. I just try all the answer choices, right? I can graph, there's my quadratic, and they're saying like y equals c, right? But c has to be one of these values, right? So I just try it. So I can try an A, and then I know that's not correct because you see that has 2 solutions, right? Or intersects in 2 places, right? But they said it should intersect at 1 point. So that's not the correct value of C. So I try B, that still has 2 solutions. I try C, and there it is, right? This is the one that has 1 solution, right? Or intersects in 1 place. Really simple because it's multiple choice, which is why most of the time that won't be multiple choice, right? Next one, they tell you it's a quadratic function, right? So again, they're going to a lot of times tell you, we saw problems before, said linear, line, model of a line, whatever, right? Exponential. They tell you a lot of times, right? That's really important, right? So here it's a quadratic function, and it says, models the depth in meters below the surface of water of a seal t minutes after the seal entered water during a dive. The function estimates the seal reached a maximum depth of 302.4 meters after 6 minutes, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what is the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? Okay, let's bring up quadratics again. Quadratics, one important thing about quadratics is when they talk about the max or min, that's always the vertex, right? The vertex is important because it's the max or min, but the vertex is also important because it's a point of symmetry, right? So here we're going to do a quadratic regression, right? But if you want to do a quadratic regression, it's really the only point, it's the only one that you kind of need 3 points in your table if you're going to do it correctly, right? So here's 1 point. It told us the maximum depth, right, was 6 minutes, and it was 302.4 meters, right? And then it gives us another point. It says it reached the surface 12 minutes after it entered, right? So what that means is, the depth is 0. If it's at the surface, the depth is 0, right? But that's only 2 points, right? So sometimes it'll be like, I don't got 3 points, right? But you always got 3 points. If you have a point and you have a vertex, the other point is just found by using symmetry, right? So it took 6 minutes to go from the depth, to back to the surface. So that implies like at 0, it was also at the surface, right? That's our 3 points. We switch it to a quadratic regression. Now we want to use our equation, right? So I want to plug in 10 for x, so I can just change that to f of x and then just ask it to do f of 10, and I get my answer, right? So that would otherwise be a really difficult problem unless you've kind of practiced it before. So that's, again, the whole key, right? Head over to Sigma Prep, do your practice. None of this should be a surprise, right? Do this test, you'll see a question just like this, right? See if you kind of remember these steps and you know what to do, you know how to find that third point with symmetry, and you know how to do your regression and evaluate it, right? So go and do your practice. Next one here. Area of rectangular region is increasing at a rate of 250 square feet per hour, right? This is going to be a conversion problem. So it's 250 square feet. What that means is going to mean feet squared, right, per hour. So that's per 1 hour. And we want to change it to square meters per minute, right? So this is just doing unit conversions, which is pretty popular and pretty common. If it's at the end of the test like this, they're always going to have one of the units being squared. You see square feet. That's why I wrote it up here. And that's going to be important because a lot of people are going to miss that, and then they're going to, fall for the trap answer that they always have. I'll show you. They probably have that here. So when you do conversions, if you did chemistry, and we've talked about this in other videos, it's just kind of doing dimensional analysis. Just make sure you multiply by the conversion factors in an appropriate way that like the units that you want cancel out and you're left with the units that you want, right? So here I'm going to do the hours first. That's a simple one, right? 1 hour is equal to 60 minutes. So here you see how I lined it up. Hours would cancel out. Now this is the tricky one, right? Feet to meters. They give you pretty much any conversion factor that you need besides like time, right? So feet's on top, I want feet to be on the bottom, right? 3.28 feet and 1 meter. So this is the mistake, people are going to make here, right? You see, if I put this in and calculate it without the units, I write the units just so I can make sure everything's lined up. But you see, this is the trap answer, B, right? This is incorrect. Why is this incorrect? Because this was square feet, right? So when I multiply by this, it's not going to cancel out square feet, right? How do I fix it? It's really simple. We just square, that conversion factor, right? So over here, you see, wrap that in parentheses, squared. Now we get the correct answer, which is 0.39, right? That's the hardest conversion problem you're going to get, right? So if you know that, and you should always expect that it'll have like units squared at the end of the module 2 test, right? Last question here gives us 2 equations. It says, in the given pair of equations, A and B are constant, and this pair of equations is perpendicular, right? So let's see, we got something over here about that. There it is. Parallel, perpendicular. You got to know these 2 words. Parallel, same slope. Perpendicular, what we're dealing with here. Opposite reciprocal slope, right? So you see over here, if I know slope is 3/5, perpendicular is -5/3. Hopefully that's pretty simple and basic for you, right? So if I have these 2 equations, you see, what I want to do is I want to first figure out what A and B are. And I can do that because they told me that these have to be perpendicular. Now, in order to kind of like, change to see the slopes, right? We have to like isolate y, which is just 2 steps. You're going to subtract 5x, right, on both sides. So it'll be 7y equals negative 5x plus 1. And then I'm just going to divide by 7, right? So this is going to be negative 5 over 7 plus 1 over 7, right? So that's what my equation turned into. And this one, I'm going to do the same thing over here, right? It's going to be subtract ax, so it'll be by equals negative ax plus 1, and then divide by b throughout, right? So this is going to be this divided by b and this divided by b. So you see over here for this one, I can see the slope. The slope is negative 5 over 7. So then my perpendicular slope is going to be what? It's got to be 7 over 5. And that's how I can figure out what the a and b values have to be, because it has to equal 7 over 5. So the way that can happen is, let's say a is negative 7, because I want to cancel out that negative to have a positive slope, and b is just 5, right? So now you see what I've done is I figured out what a and b are, and then this is really easy from here. It just wants to know which of these are perpendicular. So now that you know a and b, you can do the same thing where you solve for their slopes, but the faster way to do that actually is just, let's graph these, right? So you want to know what perpendicular lines look like on a graph, and they should just form like a perfect X or T shape, right? And they intersect to form right angles, right? So you see, because Desmos knows already what a and b are, I can put in answer choice A, it'll graph it. That's not a nice looking X or T, so those aren't the perpendicular ones. So I just changed, the second equation to be plus by, and there it is, right? This is like our perfect looking X or T, right? Just to make sure you can go through the other ones, like let me enter in C over here. Yeah, that's not it. And then we can enter in, the last one, 5x minus 7y equals 1, and then ax plus by equals 1. Yeah, that's not it either, right? So it was b that had that perpendicular shape, and that's it. That wraps up module 2 there, right? So honestly, test 9, I think probably one of the easiest tests there, right? So that should be an easy 800. So let's go. And there it is, perfect 800. Now look at the score report for a second. You get your score and a general sense of how you did in each domain. That's about it. On Sigma Prep, you get specific feedback. You'll know exactly which subtopic inside each domain every missed question came from. And OneClick builds you a custom practice set for those exact concepts with video explanations on every problem. You stop guessing what to study. SigmaPrep.io, link in the description. Like and subscribe. Next test coming soon.